here's the screencast for Unit 1, Objective number 3. We're going to talk about the different states of matter. A lot of this stuff I would hope would be common sense to you, as we're going to be talking about solids, liquids, gases, and plasma, but we will go through and identify different properties of each one. So when we talk about matter, one of the things that we need to make the distinction of is the difference between mass and weight. So whether we're talking about a solid, liquid, gas, or plasma, it's all matter. It all has mass and takes up space. But the amount of matter that an object actually has inside of it is its mass, whereas weight is affected by gravity, so it is not constant. Your weight will change depending upon the gravitational force pulling you down. So if you go to the moon where it has half the gravity, you would weigh about half as much. Your mass stays the same though. You don't actually lose any of the matter that's inside of you. Okay, so phases of matter. The first one we're going to talk about is a solid. Definite shape, definite volume. So you can take you can look at it and it has a definite shape. If I put it in a container, it's not going to take the shape of that container, and I can't compress it down. It's got a definite volume. It's not going to be expanding or compressing down very easily. They will expand slightly when heated, but not enough to really be able to notice it. A liquid has a fixed volume, but it has variable shape to it. So a liquid will take the shape of the container. A gas has variable shape and volume. You can compress it down. You can allow it to expand. So gases have the widest range of different shapes and volumes that they can take up. Just something to keep in mind, the difference between a gas and a vapor. A vapor is a solid or a liquid in the gaseous phase. So like when water becomes a gas, we don't, like steam, we don't say it's water gas, we say it is water vapor. And then plasma is a gas at a very high temperature. A little bit about the difference in the four different states of matter. So what happens to density as energy increases? So looking at this, we've got our three states of matter, and then that fourth state, the plasma, which is kind of a unique state. But our three main states of matter, the solid, you can see that the particles are already condensed together. They're already really close to each other. A liquid, the particles are a little further apart, and then a gas, the particles are really far apart. This is why a liquid will take the shape of its container, and a gas, this is why a gas can expand, but a solid is pretty much stuck the way it is. These are all attracted to each other, and they're already compressed as much as they're going to be compressed. As we lower the temperature, or we take out the energy, you get a gas to become a liquid, to become a solid. So by lowering temperature or by taking out energy, you can get a gas to change to a solid. By raising the temperature or by increasing the energy, you can get a solid to become a gas. What you need to do is get the energy between these particles higher, and it causes them to vibrate. If they vibrate a little bit, they become a liquid where they can break that attractive force. And then if they continue to vibrate so much that they break that attractive force completely, they become a gas. So a solid, you could think of them as like the babies. They still need each other. They still need a lot of guidance and support and help. Liquid, you can think of them as teenagers. They're starting to break apart from mom and dad. And then gas would be adults. You're completely on your own. And plasma, we'll talk about here in just a second. So what happens to density as the energy increases? Well, it's going to become less dense as we increase the energy. So difference between a gas and a vapor, we've already discussed this. A gas is something that is a gas at room temperature. So example, oxygen, nitrogen, carbon dioxide. Whereas a vapor is something that is normally in a solid or liquid state at room temperature, but will become a gas. So we would say that it's like gas fumes. You might say gasoline fumes. It would be the vapor coming off of there. It's not going to be a gas normally at room temperature. It's normally a liquid. So here's some examples. Helium balloon and then steam coming off the water vapor. So a little bit about water. Water is pretty interesting in that it's the opposite of most things. As the energy increases, so you have more energy, it actually will become less dense, and so it becomes more dense. Then the solid is. So that is why ice, which is less dense, will float inside of liquid water. So the density actually increases as you go from a solid to a liquid, which is the opposite of most other things. But it still maintains the same, properties as everything else. The solid, you can see that there is quite a bit of space in here. Those bonds actually expand with solid water instead of getting closer together like every other substance on the planet. So, but still, the liquid takes the shape of a container, gas, and then plasma. So a little bit about plasma. We're going to do a plasma demo. I have a plasma ball that we're going to see. Plasma has an indefinite volume and a definite shape, so it is like a gas, and it will take the shape of the container. It will expand to fill a container just like a gas, but you can think of it as ionized gas, meaning gas with charges. That's what those positives and negatives were. So there's so much energy with these gas particles that the electrons are ripped from the nucleus by heat or by electricity, and so because these electrons are ripped off, they'll now respond to magnetic fields. Lightning is an example of plasma, gas that is just so hot that the electrons are stripped from those atoms, and now you've got the different poles, the positive and the negative poles. Here's some examples: St. Elmo's fire, stars. You can find plasma in stars. Flames is a plasma. There's a plasma ball, which we're going to look at. Fluorescent lights, the aurora borealis, the northern lights, and then neon signs. The gas in here is usually under such high, or it has electricity with it, so it turns it into a plasma state. So we're going to watch these videos in class. Don't worry about doing them right now, and the plasma ball demo we're going to do in class. So the heating curve of water. This is something that we could do this in a lab, but I kind of feel that it's a little common sense. If I want to get water to go from a solid to a liquid, and then from a liquid to a gas, I have to give it energy. So that's what this is showing. I have to heat it up. At 0 degrees, water will be a solid. As I add heat energy to it, I can get it to become a liquid. Once I reach a certain point where I start getting above 0 degrees Celsius, it will stay a liquid, stay a liquid, stay a liquid, stay a liquid. And then when I reach 100 degrees Celsius, which is the boiling temperature of water, I get it to go from a liquid to a gas. And then it will stay a gas at all of these temperatures above. This is a heating curve, because it's showing that while it's melting from a solid to a liquid, it will stay 0 degrees Celsius. While the liquid is going from a liquid to a gas, it will stay 100 degrees Celsius. Once all of it turns into a gas, that's when the temperature will rise. Once all of the solid turns into a liquid, that's when the temperature will start to rise. We call it the heat of fusion, which is what the HFUS means. That is going from a solid to a liquid or a liquid to a solid. That's the heat of fusion. The heat of vaporization is the HVAP, and that is going from a liquid to a vapor, so changing from one state of matter to the other. So this is just showing how the different temperatures that water changes state. So water, we know, changes at 0 degrees Celsius and 100 degrees Celsius, but every substance is going to have its own boiling point and its own freezing point, and that's what this would be. Here's the freezing point, and here would be the boiling point. The triangle just means change in, meaning you are adding more, so you're getting it to change. So any transition in physical change, either adding or removing energy. So any transition is going to be that physical change. We're going to do an activity with phase transitions or phase changes, but I would hope that this is something that you guys already know, at least most of them. So going from a solid to a liquid is what we call melting. Going from a liquid to a gas is vaporization, so it's becoming a vapor. You might also see that as boiling. Going from a gas to a liquid is condensation, so like when you have dew on your car, or when you take a hot shower and you end up with moisture on your mirrors in your bathroom, that's condensation. And then a liquid to a solid is freezing. Going straight from a solid to a gas is called sublimation. Going from a gas to a solid is called deposition, and going from gas to plasma is ionization. So these are the basic changes of states of matter that we will go through with our phase transitions. This diagram here shows you the names also again. So we've got going from a solid to a liquid, freezing, melting, depending upon which way you're going. Going from a liquid to a gas, vaporization, condensation, depending upon which way you're going. And then going straight from a gas to a solid or solid to a gas, we've got deposition and sublimation. Gas to plasma, ionization, and then plasma to gas would be recombination. So it's going back into the gaseous form. Enthalpy is just the chaos of the system. And so the more chaos there is, the more energy there is, the more enthalpy there is. So a solid has less energy than a plasma does. So that's why the enthalpy of the system increases. And like I said, we are going to do some activities with solids, liquids, and gases, the properties of each in class, as well as watch the videos about plasma, do the plasma ball demonstration, and then we will do a simulated lab on phase transitions.